All right, Trig, we're going to talk about, here's your video for Tuesday, May 13th. We're now talking about ellipses. Yesterday, you guys talked about, had some notes on circles. An ellipse, given two distinct points, F1 and F2. In the plane at a fixed distance, D, an ellipse is a set of all points, X, Y, in the plane such that the sum of each of the distances from F1 to F and F2 to X, Y is D. F1 and F2 are called foci of the ellipse. We didn't talk about foci last year at the end of college algebra. They are part of the analysis of an ellipse. Now, last year, we talked about x squared over a squared plus y squared over b squared equals 1. We said that a is always bigger than b. A is associated with the major axis. Now, here we're going to have a center that is not 0, 0. It's not going to be on the origin like it was last year. Okay, then we also have, all right, so that's, again, so a squared is always bigger. So a squared could be here, b squared could be there. A is always bigger than b, so that is also something we want to know. Here's an alternative alternate form, but again, that is what we're going to work with. All right. So we will graph some of these. Notice here, example 1, we're going to graph the following. Okay, so first off, the center would be at -1, 2. Remember, for a hyperbola and ellipse, it's always set equal to 1. Okay, 25 is bigger, so we would say a squared is equal to 25. A is 5. We would say b squared is equal to 9, so b is 3. So you have a center at 1, -2, which I did not copy through that page. Anyway, here's what you would do. All right, we'll graph some together. But anyway, you have a center at, -1, 2. Okay, and then a squared is 25, and it's associated with the y-axis. So you would go like up 5. We'll assume that's down 5, and then b squared is 9, so b is 3. You go like over 3, over 3. It's elongated vertically because a squared is under y squared, which is associated with the y-axis. All right, so it looks like that, kind of a football. Okay, what else here? To write it in standard form, we're going to do completing the square twice. Okay, I'm going to do completing the square twice, as you see here. This time, though, it has to be set equal to 1. So like with the circle, it could be equal to 4. R squared is 4. You have a radius of 2, but it's got to be set equal to 1. So we divide that by 4. We're going to divide this by 4 to get the following. So we'll do a few of those examples here in a second. Okay, which is actually right now. All right, so our notes are going to be a little bit quicker for this on the ellipse side, and then we're going to talk about the Math 111 SIUC final exam little assignment that we have. All right, so you've got paper here, ellipses, exercises, page 13B in this packet you don't have. So I want to graph this. All right, x minus 2, all of it squared over 4, plus y plus 3, all of it squared over 9. So b squared is equal to 4, a squared is equal to 9. So the center is going to be 2, -3. The center is going to be 2, -3. That's the first thing we want. From the center, we go left, right, up, and down. The center is 2, -3. Now, 9 is bigger, so it's a squared. A squared equals 9, not a. A squared equals 9, so a is 3, and it's associated with the y-axis. B squared is 4. Again, b is the smaller number. B squared is the smaller number that is. So b is 2, and it's associated with the x-axis. So I plot the center 2, 3 first. Here's the center 2, 3. And then I go 2 to the right, x-axis, to the left, that's B. Then I go 3 up, 3 down. It's a little bit too much there, so it's not great. It is, again, elongated a little bit more vertically. So if A and B are pretty close to each other, it's going to look more like a circle than an ellipse, like an oval, that is. It's going to look more like a circle. It's not a circle because A doesn't equal B. That's how you graph it. Again, pause this whenever you need to. All right, so like the one we just did, we're going to graph it. All right, so you have x plus 5 squared over 16. You have y minus 4 squared over 4. This time, a squared is associated with the x-axis. A is 4, associated with the x-axis. B squared is 4, so b is 2. It's associated with the y-axis. And the center is negative 5, positive 4. Negative 5, positive 4. All right. So I go plot negative 5, positive 4. Then I go 4 to the right, 4 to the left, 2 up, 2 down. This is like sort of better. It definitely looks like an oval there, elongated horizontally big time. All right, sort of better. A lot of things are elliptical in nature, in orbits. All right, and or your eyes. Okay, so then we have the following here. So we're going to write equations in standard form. Okay, again, completing the square is going to be a big deal for us next year in calculus. So you've got that. So your first task is to put the x's together, get the y's together. So I'm going to add 119 to both sides. Add 119 to both sides. So I'm going to get x squared minus 54x, x squared minus 54x, 25 y squared minus 50y. I'm going to factor out the 9 that we have in common here. We kind of did that yesterday with the circle. We definitely have to do that today. So in order to do completing the square, you need a single x squared or a single y squared. So I need to factor out the 9 that these both have. Now when I do that, now I can complete the square. What is half of negative 6? Half of negative 6 is negative 3. Negative 3 squared is 9. It's always a positive. I'm not just adding 9 to the left. I'm adding 9 times 9, which is 81. 119 plus 81. All right. Then here I factor out the 25 that they both shared, leaving me with y squared minus 2y. I'm going to take half of negative 2, which is a negative 1. I'm going to add 1, and I'm going to get 25. 25 times 1 is 25. Okay, that gives me 225. 9 times x minus 3, all of it squared, plus 25 times x minus 1, all of it squared is equal to 225. I need this to be equal to 1, so I need to divide everything by 225. 225 divided by 25 is 9. 225 divided by 9 is 25. And now I am in standard form. Awesome. Okay. On 14, x squared plus 5y squared minus 24x plus 20y plus 14 is equal to 0. I'm going to move that 14 over. Then we need to move the negative 24x. We need to put it with x. And the 20y, we need to put it with y. 6x squared minus 24x. I'm going to divide by 6, factor out the 6. Negative 4y is what I'm left with as my middle term. I'm going to take half of negative 4, which is negative 2. I'm going to square it to get 20. I'm going to square it to get 4. Now, I'm not just adding 4 to the left. I'm adding 24. So I'm going to put a plus 24. I'm going to take half of 4, and I'm going to get 2. I'm going to square 2 to get 4. All right, what am I adding to the left? Not just 4, but 5 times 4, 20. So I'm going to put a plus. That is a 20, not 10. All right, hopefully I made a mistake. I wrote 10 down originally. Oh, that's going to make it much easier. Nice. First I was like, uh-oh, 20. I'll have to show the work later. Nope. All right, this is looking good. Okay, so again, I can't have it set equal to 30. I need it set equal to 1. So I'm going to divide everything by 30. 30 divided by 6 is 5. Y plus 2 over 30 divided by 5 is 6, and that's equal to 1. And that is in standard form. And that is some sweet completing a square. The hardest completing a square, we'll talk about tomorrow with the hyperbola. All right, again, we are looking at now our SIUC pre-calc final assignment. Again, this is going to be due on May 19th, Monday, May 19th. All right, we have done 1 through 3 in class. We did 4 in yesterday's video. Here's number 5. Solve each equation, use exact values. No calculators, decimals. We're allowed a calculator on this, so I'll show you. Exact answers are like 2 pi thirds, 4 pi thirds, that sort of thing. All right, so you're going to treat this as 2x squared minus x minus 1. How would that factor? A 2x and an x. How do you get negative 1? So product, 1 and 1. One's going to be positive, one's negative. That is a positive x, or cosine theta. That is a negative 2x, or a negative 2 cosine theta. That's what we need. So we have 2 cosine theta plus 1 equals 0. Cosine theta minus 1 is 0. Cover-up method. 2 cosine theta equals a negative 1. Cosine theta is a negative 1/2. Cosine theta minus 1 is 0. So cosine theta is 1. This one's a little easier. Where on the unit circle do I have a cosine value of 1? And that is at the beginning. That is 0. It's technically 2 pi, but look at that. You have a parenthesis. That means doesn't include. So we're going to say 0. If I have cosine theta as a negative 1, where on the unit circle do I have an angle with a cosine ratio of negative 1/2? So cosine is x. X is negative in the second and third quadrant. In the pi thirds family, it is, again, you can do cos inverse of 1/2 and you'll get 60 degrees, which means it's in the pi thirds family. You just need to know it's in the pi thirds family. Second quadrant pi thirds is 2 pi thirds. A third quadrant pi thirds member is 4 pi thirds. Those are your answers. Okay. B. Sine 2 theta is equal to root 3 over 2 on that interval. All right, so what we're going to do is, first off, where on the unit circle is sine theta? Or where in the unit circle do I have an angle with a sine ratio of root 3 over 2? So first off, sine, I know it says 2 theta, but sine is positive in the first and the second quadrant. And in the pi thirds family, sine has, those angles have a sine ratio of root 3 over 2. Then you do sine inverse root 3 over 2, you get 60 degrees, pi thirds family. So first quadrant, pi thirds family is pi thirds. Second quadrant, it's 2 pi thirds. So I'm going to say 2 theta is equal to pi thirds. Pi 6 is your answer. 2 theta is equal to 2 pi thirds. It's 2 pi over 6, which is pi thirds. Now, technically, the reason why I said those should be fine is because you're looking for answers between 0 and 2 pi. So actually, if you add 2 pi to this, you get 7/3 pi, and you're like, but that's over. But not if you divide it by 2. So technically, 7 pi over 6 should count. And if I add 2 pi to this, I get 8 pi thirds. But if I divide it by 2, I'm going to get 4 pi thirds. So they might be looking for that. I wouldn't. I would just say that. Okay. Find the general solution to the following. Okay, so the reason why you don't want to just divide both sides by sine x and be like, I'm done, then you get tan x equals 1, and that's true, but you're also going to miss the times when sine x equals 0. Okay, so you actually want to move the sine x over so that you have sine x tan x minus sine x equals 0. Going to factor out the sine x they have in common, leaving you with tan x minus 1. Cover-up method says sine x equals 0. Cover-up method says tangent x minus 1 is 0, tan x is 1. Where on the unit circle is sine 0? It's 0 at the beginning and at pi, so 0 in pi. Where in the unit circle is tangent 1? Tangent 1 is in the pi fourths family, at pi fourths and 5 pi fourths. Tangent is 1. At 3 pi fourths and 7 pi fourths, tangent is a negative 1, and that is not what you are after. Okay, just like we did yesterday. Actually, we're going to do this real quick. All right, so turn the page. A little into the class assignment might be coming, might have a surprise. All right, some of these we're going to do in class, like number 12. That's going to be a good one. So given g of x is equal to 2x to the third plus x squared minus 8x minus 4, give the y-intercept. But the y-intercept is an x is 0, so it's staring at you. It's negative 4. Give the factored form. How would you factor this? You're going to factor by grouping. Anytime you have 4 terms, you're going to use factoring by grouping. These first 2 terms have an x squared in common. leaving me with 2x plus 1. You always bring down the sign in the middle, so a minus. What do 8x and 4 have in common? You can divide them both by 4. Now you're dividing by a negative 4. Negative 8x divided by negative 4 is a positive 2x. Negative 4 divided by negative 4 is a positive 1. 2x plus 1, I see it twice. And I also have x squared minus 4 on the outside. Remember, they get grouped together. If you wanted to receive full credit for, factoring it in the most simplest form, you would factor x squared minus 4. X squared minus 4 is x plus 2x minus 2, leaving you with 2x plus 1. Okay, then let's take a look at my zeros. Okay, so I just set it equals 0, so I get a 0 of negative 2, positive 2, and negative 1/2. Negative 2, negative 1/2, 2 multiplicity. None of these are squared, so they all have multiplicity 1. And we talked about this Thursday in class. So it would actually, because you don't have a multiplicity of 2, that doesn't mean it's not a tangent. It doesn't hit that point, then bounce off. So it's going to cross through on all of them. Now, we're not going to graph this. But what's the end behavior? So take a look at this. This is the third power. Third power is odd. So the end behavior for odd, we said last year odd was opposite. Remember, we had the LC, the leading coefficient is positive, so it ends by going up. The leading coefficient tells you how it ends. It ends by going up. In the other direction, it goes down. It goes down in the other direction. We won't graph that right now. We don't do a ton of graphing in calculus. Let's end here with number 8. What is the vertex? Next year we'll do a derivative to find the vertex. We'll take the derivative, set it equal to 0. But last year we learned the vertex was negative b over 2a. That is b, that is a, which is 1. So the opposite of 6 over 2 times 1 is going to be negative 6 over 2, negative 3. That is the x-coordinate of the vertex. How do you find the y-coordinate of the vertex? You plug negative 3 in for x. Negative 3 squared plus 6 times negative 3 minus 7 is going to give you negative 16. The vertex is negative 3, negative 16. What's the y? We could find the y-intercept. It's staring right at us. Y equals negative 7. What are the zeros? So you're going to set this equal to 0. 0 equals x squared plus 6x minus 7. Well, multiplies to 7 and differs by 6. But there's only one way to get 7. It's 7 and 1. Middle term's positive. X plus 7x minus 1. Cover-up method gives you x equals 1, x equals negative 7. And we don't need to graph that. All right, so there will today be no assignment that you need to turn in at the end. So be on the lookout. That could happen tomorrow. But this is Yak Math Videos signing out.